First of all, thanks a lot to organizers. It's great. It's very rare when geologists are involved into the discussion about the climate change, and actually it's really strange. Once, when I was preparing the lecture like this one, I made the experiment. I asked the question to my colleagues and family. The first word which you're thinking about mentioning climate change, and as you can see, even among my colleagues geologists, nobody mentioned geology. If we will have a look at the list of HELCOM parameters of climate change fact sheet, again you will find just three more or less terms which more or less link in with geology, like sediment transportation, erosion and sedimentation, and maybe hazardous substances. And of course, in our official level in the ministries, nobody think that geologists should take care about climate change. Geologists should find the resources. And of course it's true, but it's a big mistake. I would like just to remind you that as long ago as in 18th century, there was started a so-called Great Geological Controversy, when for the first time, very high in the mountains, in sedimentary rocks, there were found some remains of ancient mollusks, and people just understood how great was these changes in environment during the past geological time. And also being here in this fantastic instituted museum, I would like to remind you about geological time, which we geologists operate. Today, when we were going along the museum, it seemed that the mankind history is endless, and the cultures is so rich, and but we should remember, we people should remember that from geological point of view, if we this scheme was proposed by Professor Sergei Romanovsky from our institute, and if we will see, we will think about all Earth history as 1 year. The first very long time, by the end of March, will be practically lifeless before first bacteria could be found, and just December 12th is the golden age for dinosaurs, and we people, we live in this planet for so short time, and our Christmas is just 4 seconds, last 4 seconds. So of course we are very important. We can transform the earth, we can even destroy it, unfortunately, but our time is very, very short. Let's remember about it. And our Eastern Gulf of Finland is a fantastic area where people lived for a long, long time, Neolithic people. And I would like to demonstrate today how huge was, again, the changes of sea level, for example. And here are some reconstructions, paleogeographical reconstructions during last 9,000 years. So as you can see, this point mark the place where we are right now. So several times during very short, from geological point of view, time, it was, for example, sea bottom. And our problem today is that actually we are not ready anymore to make it sea bottom again. So the coastal zone is very important for the mankind. As we know, approximately 50% of world population lives in a very narrow strip of about 100 kilometers from the coastline, and a lot of huge cities are located along the coast as well. Also, coastal zone, both onshore and offshore, is fantastically very, very important from environmental point of view, from biodiversity point of view. And also our coasts are just very wonderful. Here are some samples of the beach. And as for the anthropogenic impact, here is the sample, the typical sample of the Neva Bay coasts. As you can see, they are not so attractive, and there could be two directions, two trends of anthropogenic impact. I suppose that nobody can tell that this is bad practice, but this is also sample from the Neva Bay. Frankly speaking, fortunately, it's these photos were made in some years ago. Now it's a bit more attractive, more tech. But anyway, there are still problems of the waste disposals, which is the important source of hazardous substances for Neva Bay and Gulf of Finland ecosystem. I have today, I will demonstrate today just 3 slides about methods, as I have no time for this. So what do we have? First, we have relict coastal forms, which could be found. We have relict coastal forms which can be found now offshore and onshore. And studying these coastal forms, we can reconstruct the sea level change, for example, for the past. And also, today Anna already mentioned the ice cores, which source for environmental information. The other, the same or different, but very important source of this information is bottom sediments of the sea. And we just took such a huge metal tubes and receive this fantastic cores, and then studying them very carefully, millimeter by millimeter, because the bottom sediments during deposition, particle by particle, layer by layer, include the information about paleo-environmental and climate change. And then we using a lot of different methods. Again, just trust me that it's possible. Of course, it's always question of discussions, but we can reconstruct the climate change and environmental changes. So what do we find about our region? First of all, it's very important, the pre-quaternary geology, which is in Finland and Sweden and represented by very solid and not erodible magmatic and metamorphic rocks, while the southern coast consists of more easily erodible sedimentary rocks. Then the formation of our coast started during the last glacial period, when the huge ice sheet was moving here, and this very well known to you base of southern coast of the Gulf was formed during this movement. And here are again the reconstructions of the last glaciation, very well known for all of you. And you can see that about 20,000 years ago, the ice sheet had the maximal extent, and after that the climate changed. During the warming, the ice sheet started to melt it. And what is important, this is the time period when the edge of ice sheet moved across our eastern Gulf of Finland. And what is very important, it leaves here the huge amount of sand, gravel, clay and other material, from which during the next time period, Holocene, was constructed all our accumulation sand forms here. And here I would like to tell you about a very short but very interesting sample of interaction of interdisciplinary research of geologists and archaeologists. It's Narva-Luga Clint Bay. And we were invited to by Dr. Dmitry Gerasimov to work together with archaeologists, and actually this cooperation was very fruitful because for us it is the place of a lot of relict accretion forms, and for archaeologists it's place of a lot of archaeological sites. And we have found, as you can see, that there is some strange triangle which is practically perpendicular to the recent shoreline. So it couldn't be actually coastal accretion form. And after some ground penetrating radar investigation, profiling, we have found a very strange, with steep slopes, sand and gravel paleodelta, as you can see. This is the reconstruction of this paleodelta, but it the layers was directed from the sea to the shore, so it couldn't be any river, and we have found that it's so-called glacial fluvial paleodelta, and the same. So in it's the grade. You can understand that this 30 meters thick layers of sand and gravel during the Holocene, when it's the same relief form on the northern coast of the Gulf. So it was the source of the future accretion form development. Wow, no. No. Well, then very fast. Here you can see the different time period, different paleobasins which represent slightly salty Yoldia Sea, then fresh Ancylus Lake, and then a Literina Sea. During this time period, as you can see, the area of the sea was much larger than today. And so, okay, here is the samples of the sea level change, just to demonstrate you how big was the amplitude of these changes during last 8,000 years. So, okay, maybe I will skip all these slides, as I would like to demonstrate you that according to results of sediment core analysis, during Holocene, there was some period of time which, during which the climate was even warmer than today. So, after the maximal of Literina transgression, the sea level started to drop, and it was very important time for from geoarchaeological point of view, as here around there was several big lagoonal systems, one in the Narva-Luva-Klint Bay, the second around Sestroretsk lowland, and this one again, ceramics, archaeological science and lagoon, and the third one in Okhta. This is some reconstruction. So what I would like to emphasize that during last 8,000 years, environmental change was very large here in our area, and people who dwell in these areas, they had a lot of time. Yes, they were not in hurry, and they just followed the coast and lived and hunted and fishing and so on. And this is, it was fantastic to me, your first slide today about coastal erosion, because it's the topic which I can talk hours and hours. And as you can see from these slides, it's very important problem for our area. St. Petersburg provide a lot of very interesting historical data, which together with our scientific method permit us to reconstruct how much was, for example, coastal erosion. You can see in Zelenogorsk a slide of young lady sitting on the top of some monument, and this level now it's somewhere here, the other young lady. So we lost about 100 meters wide and about 4 meters high beach. So coastal erosion, here I can, again, trust me, now we have a lot of very long coastal monitoring, and we know how does it happen and why doesn't happen. And what is important from our today point of view. We observe extreme erosion event during this coincidence of these three factors. And as you easily can see, they are climate dependable. So once we had a very interesting project together with our Finnish colleagues during this project, we are trying to present some kind of forecast of future development, and unfortunately it's not very good, because we are going to lose a lot of very our fantastic beaches in future. And there are two possible adaptations. We can escape or we can struggle. But how should we struggle? This is the worst possible decision, concrete seawalls, just several slides with no comments. And this is best possible decision, just very gentle measures when we understand the nature, the natural appropriateness, and just help nature to construct the beach. So it's sand nourishment, artificial beaches, and some such decision like, for example, these artificial ridges, when we construct actually a submarine barrier preventing the coast from the erosion, but it is dwelling by animals and vegetation, and it's artificial ridge, which is beautiful decision for coast protection, for tourism, and for ecosystem also. And my last several slides a bit sad, because here are examples from our region. You can see the bad coast protection practice, which unfortunately prevail now in the Eastern Gulf of Finland. 2006, you can see the beach between Solnične and Trepina, and after that concrete wall, and after that situation is worse and worse and worse, and yeah, it's Lysinos. It's very fresh sample of fantastically stupid coast protection, very recent. So yeah, this is my last slide, that it depends on us. It's a bit very Russian. I don't understand. I'm not sure that it's possible to translate into English. But our anthroposphere can be noosphere or sphere of razuma, sfera razuma, or technosphere. Thank you very much.